The carbonyl group is a carbon double bonded to an oxygen. To determine the reactivity of the carbonyl group, we must look at the two other groups attached to the carbon atom. In these examples, we will assume one of the groups is an R group. An R group denotes a simple alkyl chain, which therefore means this atom is carbon. As a result, for carbonyl reactivity, the R group can largely be ignored. The X denotes a variable group, in which this atom can be anything. However, it is typically an oxygen, nitrogen, or chlorine. There are two main factors to consider when evaluating a carbonyl's reactivity: the conjugative effect and the inductive effect. Suppose we wanted to compare the carbonyls in an amide and an acid chloride. We can take the amide as an example for the conjugative effect. After omitting the atoms which are not contributing significantly to the reactivity, we are left with these three atoms. Viewing the molecular orbitals can give us a better idea of what is going on. There seems to be possible overlap in this region, and if we were to take the nitrogen lone pair as the HOMO and the carbonyl pi star as the LUMO, we could form a combined orbital that looks like this. By drawing an MO diagram, we can see that this interaction produces a more stable HOMO due to the lowering of the energy of the nitrogen lone pair. We have also produced a more energetic LUMO, which is now likely to have a poorer energy match with incoming nucleophilic HOMOs. Hence, the carbonyl has been reduced in reactivity. This is the conjugative effect. If we now look at the acid chloride and consider the same three atoms, but this time look from an electrostatics perspective, the chlorine and carbon have a significant electronegativity difference, meaning the chlorine will withdraw some electron density from the carbon, thereby making it more positively charged. This increases the likelihood of an interaction with a negative charge on a nucleophile, hence making the carbonyl more reactive. This is the inductive effect. In all carbonyls, these two effects are both active, and so the reactivity is not necessarily trivial to determine. To make a good judgment, you must weigh up the contributions from both effects and try to work out which effect would be dominating. Here is a selection of some common carbonyl functional groups and their reactivities so you can see the two effects competing.